Memory, hints, and retrieval help small models reason. Small language models can improve at math without changing their weights if you teach them to remember and retrieve their own strategies. A local experiment inspired by Google's reasoning bank shows Qwen 3-1.7b instruct, jumping from 40%-48% accuracy on math level 3 to 4, with a memory bank of strategy snippets extracted from its own successful solutions and inserted as hints at inference time. The setup emphasized rigor, filtering out any hint that could leak answers, deterministic seeding, and Wilson intervals. The author notes overlapping 95% CIs and calls for larger test sets. Interestingly, the 1.7b model benefited more, but with some regressions, than Qwen 3.4b, which saw a smaller plus 4% gain without regressions, consistent with the idea that tiny models have more to gain from missing strategies but are more fragile to prompt noise. Code is open-sourced, and Phase 2 will try fine-tuning LoRa on the model's own successful traces to bake in strategies and iterate. A broader, production-ready take on persistent local memory comes from Reasoning Bank, presented as a self-learning, local-first system that stores and retrieves reasoning patterns with confidence weights. The author claims 34% task effectiveness gains, 16% fewer interaction steps, and 87 to 95% semantic retrieval accuracy, with low-latency SQLite-backed queries and no retraining required. The V2 Alpha 10 release ships pre-trained databases and integration docs, emphasizing local durability and token savings via shorter prompts. These are ambitious claims, and the assets are available for scrutiny. On the retrieval side, query transformation may be the bigger lever than embeddings for many RAG systems. A practitioner compared 9 techniques and found 3 consistent winners. HIDE, generate a hypothetical answer and search against it, RAG fusion, multi-query plus re-ranking, and step back, ask more abstract questions first. The thread's best observation: many teams overtune embeddings while underinvesting in query formulation. One commenter notes that HIDE-like benefits can be shifted to ingestion time by storing extra question embeddings per chunk, trading disk for latency in interactive settings. Attention limits, robustness, and long context. A new Araxiv paper dissects a quiet failure mode of softmax attention. As more tokens are selected, attention becomes less selective, trending toward uniformity, with training also becoming touchy at low temperatures. The authors provide a theoretical framework with separation bounds and validate on GPT-2, arguing for more robust normalization and selection strategies. The takeaway is not a crisis, but an increasingly relevant constraint as contexts and candidate sets grow. Security researchers are connecting dots between attention behavior and prompt injection risk. A CISO in residence surveys work showing instructions can distract models away from original goals. One paper even tracks attention shifting from primary tasks to injected text during successful attacks. The piece is careful. Evidence suggests attention and obedience interact, especially with long contexts, but causality is unproven. Other factors, instruction tuning, RLHF over-obedience, recency bias, RAG, agent pipelines mixing trust boundaries, decoding choices, also plausibly drive vulnerabilities. Teaching instruction hierarchies helps, yet it doesn't settle whether longer context directly enables attacks. It's a useful research agenda, not a closed case. Meanwhile, training methods are adapting to long reasoning traces without quadratic cost. McGill's Markovian thinking reframes the RL environment so the model reasons in fixed-sized chunks, periodically resetting the prompt and carrying forward a short textual state. Their DILA-think approach keeps state bounded, e.g. 8K, matching or beating long-cod RL with far less compute and continuing to improve beyond the trained budget, reportedly enabling up to 128K thinking tokens. They also observe signs that some frontier models already exhibit Markovian thinking zero-shot. It's an elegant way to decouple long reasoning from runaway context costs. Local and edge AI get faster, lighter. The local edge scene was unusually dense this week. Highlights: NVIDIA's fast DLLM v2 hits 2.5x decoding speed over standard autoregressive with only 1B tokens of fine-tuning. RND1 releases as an open diffusion language model. Helix debuts a 7B multimodal thinking model sized for local deployment. Stream Diffusion v2 runs real-time interactive video on consumer hardware, 16.6 FPS on 2x RTX 4090. Paris demonstrates decentralized training of an open-weight diffusion model. Meta's SSDD accelerates image tokenization 3.8x, a drop-in KLVAE replacement. Canny TTS 370M delivers lightweight TTS. And VLM Lens ships a toolkit to interpret local vision language models. It's a reminder that local now spans text, vision, and audio at usable speeds. Liquid AI's LFM28BA1B takes a different angle. A hybrid MoE with 8.3B total parameters but only 1.5 bits active, claiming on-device quality near 3 to 4B dense models and speed faster than Qwen 3 1.7B. Quantized variants are meant to fit high-end phones, tablets, and laptops and run with llama.cpp. If these claims hold across tasks, MoE on device may become the default for edge assistance. On the heavy side, a community ABQ quant of Boson AI's Higgs Llama 370B compresses a 140GB model to 37GB, small enough for 40GB consumer GPUs. The thread is a good reminder to evaluate with more than perplexity. Community members point to metrics like KL divergence for fidelity after quantization. Is CPU-only local worth it? It depends. One dev reports 10 to 15 tokens sec on sub-20B models with a 13th Gen i7 and 64GB RAM, while others caution that agentic coding will feel slow and quality won't match GPT-4 class systems. AMD DGPUs can help, e.g. 6900 XT, but the consensus is to temper expectations and pick models carefully for the workload. MCP-powered agent integrations grow up. If agent apps are the new web apps, the Model Context Protocol MCP is shaping up as their HTTP. Material pitches itself as Versal for MCP, a developer platform to connect any model to thousands of tools and data sources in one function call. It abstracts MCP complexity behind SDKs, TS/JS, Python, handles OAuth session management, logs every session with detailed error reports, and lets you test any MCP server in an embedded dashboard. It's open source and self-hostable, though the hosted path is the fastest on-ramp. Beyond tooling, the marketplace around Claude Code plugins is exploding. One tracker jumped from 24 to 115 listings in days. Whether these consolidate or fragment is anyone's guess, but the speed signals both demand and low barriers to entry for MCP-aligned tools. DIY LLMs from 100 chats to RL coders. Andrei Karpathy's NanoChat is a compact, hackable end-to-end LLM stack. Training, inference, and a web UI in about 8K lines of code. The pitch: rent an 8x H100 node for $24 per hour. After 4 hours, 100, you get a conversational model. 12 hours slightly nudges past GPT-2. The default is a 561 million parameter model trained first on 24 gigabytes of curated web text, then on 568K instruction examples, and finally some preference-style data, small enough to run almost anywhere. A community member even coaxed it to run on CPU on macOS. It's not state-of-the-art, but it's transparent, end-to-end, and cheap enough to learn with. For a slower burn pathway, a practitioner's series on building an LLM from scratch hits the milestone where the stitched-together architecture finally trains and talks back, even if only on 20K characters of Edith Wharton. It later loads GPT-2 weights onto the hand-built model. The post is short, but the lesson stands. Carefully assembling the pieces pays off in understanding. On the other end of the spectrum, Quaipalat's CatDev 72B Exp opens a large RL-tuned coder model with strong SWE bench-verified results, 74.6% under the SWE agent scaffold, with specified temperature turn caps. Under the hood, they rewrote the attention kernel and redesigned training around shared prefix trajectories for efficiency, and reshaped advantages to prevent exploration collapse. It's a window into how Big Coder RL is evolving, with practical scaffolding and inference configs provided. Science, security, and scrappy engineering. Google's C2S Scale 27B, a Gemma-based foundation model for single-cell analysis, reportedly helped generate a novel hypothesis about cancer cell behavior, with open weights, code, and a bioarxiv preprint available. The work highlights LLMs as scientific reasoning partners, not just text predictors. A cancer researcher in the thread adds healthy skepticism. The novel finding amounts to a particular combo of immunostimulatory compounds working in cell culture, which may not be surprising and may not translate in vivo. The open release invites independent evaluation, which is exactly what's needed. Security-wise, Apple's iOS architecture keeps inching toward microkernel-like compartmentalization. A new analysis explains SPTM as the authority for memory retyping, creating trust domains that gap functionality like TXM, code signing entitlements from X and U. It also details exclaves and their communication via XNU proxy and the Typebeam IPC framework. The upshot: more sensitive components move out of the kernel's direct reach, raising the bar even if X and U is compromised. Two small but useful engineering notes. First, a tiny Go Fiber service that returns your public IP accurately, even behind CDNs, demonstrates impressive concurrency with 21 millisecond average latency under heavy load, and ships a systemd setup for production use. Simple tools, well executed, still matter. Second, Hackaday's Component Abuse Challenge features a delightful blast from the Beam robot past, driving a tiny motor using a 74ACT139 demultiplexer. It works because the motor's draw is minuscule, but the point is creative constraint bending, not a new motor driver standard.